Alright guys, hi, I'm Max, and today we're going to be talking about half-lives and how to solve problems involving half-lives. So, a half-life is what we use to describe how fast the decay process happens for a radioactive element, right? So think about a half-life in terms of the original amount that we start with, right? So if we start with 100% of our material, over time, it's going to decay and it's going to disappear. So half-life is how long it takes to get from 100 to 50% of the material, right? So that's the length of our half-life, and that is denoted by T1 half, all right? So now, if we start at 50% and go to 25%, so we divide by half again, it's going to take the same amount of time, and that's what a half-life is. And even if you go further, back divide again to 12.5, it's going to be the same length because it's the same amount of time. All right. So now let's look at a practice problem. Because the purpose of this video is to describe how to solve problems involving half-lives. So that's what these questions are. We're going to have about 3 practice questions, right? So the first part of a problem is to define your variables. So figure out what you know and what you don't know, right? So there's 4 variables for these problems, right? So they're going to be these right here, right? So what's the total decay time? What's the half-life? What's the initial amount? And what is the amount after our decay curve, which is MT, right? So let's look at what these are going to be. So our half-life of cesium-137, it says it's going to be 30.2 years. So let's write that right here, 30.2 years. So it says the initial mass of the sample is 1 kilogram, so that goes right here, right? 1.00 kilograms. So, and then it says how much will remain after 151 years. So we know the time there, that goes there, 151 years, and we want to know how much will remain, which is MT. So the second step is to find the number of half-lives. So find the number of half-lives. And the way we do that is find the variable that we have 2 for. So in that case, it's going to be our time variables. We have both of those values, right? So it's our time variables. So to find the number of half-lives, you simply take the total time and divide it by the number of half-lives. So for example, for this one, it's 151 years divided by 30.2 years. So what's that going to equal? That's going to equal, let's see, 5 half-lives. So cesium-137 is going to go through 5 half-lives in 151 years. So the second step is to utilize the equation. So the equation looks like this. MT equals our initial mass divided by 2, and in the exponent we have the number of half-lives. Alright, so now we simply plug in our variables. So for initial mass, we got 1.00 kilograms divided by 2 to the, and we just got 5 half-lives, so the exponent's going to be 5. So this is going to be, and I already calculated this out, it's going to be 0.03125 kilograms, all right? So after 151 years, cesium-137 decays from 1 kilogram to 0.03125 kilograms. All right. So this next problem is a little bit different, but we're going to start it the same way anyways. All right, so let's define our variables. What is our M, our mass, our initial mass, and our final mass, MT. What is our time? Let's put that here, that the decay process occurs over, and what is the length of our half-life. All right. All right, so let's pick these numbers up out of the question. So the half-life of carbon, it says, is 5,730. So let's put that right here. It originally contained 24 grams of carbon-14. So that's going to go at the initial mass. So, and then it tells us it now contains 1.5, so we have that value as well. Sorry for that, 1.5. And now we want to know how old the sample is. So this time, the variable we want to figure out is t. All right, so the second step is the same as the other problem. So let's find the number of half-lives. All right, so we're going to use the two variables that we know, just like last time. Except this time it's a little bit different because it's the two mass values, right? So we have, it's a little bit different as well in this way, because think about it. We have 24 grams, and we're going towards 1.5 grams in the end, right? So how many times do I have to divide by 2 in order, oh, my bad, in order to get there, all right? So how many times do I divide by 2 to get to 1.5? Right, so after 1 dividing by 2, we get 12, all right? And then we divide again, and then that gives us 6. Divide that by 2, we get 3, and divide 3 by 2, we end up equaling our amount of 1.5. So how many times do we have to divide by 2? Let's count this. We have 1, 2, 3, and 4. So that means carbon-14 underwent 4 half-lives. So now that we know how many half-lives it went through, and we know how long each half-life takes, which is 5,730 years, we multiply 4 times times 5,730 years, and that's going to give us the total time. So let's put that in the calculator over here. And that is going to give us 22,920 years. All right, so it's a different kind of problem, but we can still solve for the variable that we want. All right, we're going to go through one more just in case. All right, so as always, first we're going to write out our variables, just like the last question. So first we got our t, and then we got our half-life, and then we got our m initial and our m final. All right, so now look at the question. Let's try to fill these out. So we can see that it says it's left undisturbed for 12.5 hours. So we have a time, 12.5 hours. And then it says only 2 grams remain. So we have the final, which is 2 grams. And then we have the initial sample, which is 64 grams, which it says right at the start. And then it's asking, what is the half-life? So the variable that we're seeking for is the half-life. So just like the previous question, we're going to have to work backwards, because we started with 64, and then we want to end up with 2. So 2 grams. So how many times are we going to have to divide by 2? Oh, my bad again. How many times are we going to have to divide by 2 or go through a half-life before we get to 2? So this is pretty basic math, but we're going to go through it anyways. So 1 half-life makes 6432, and then another half-life makes it 16, and then another one, then we have 8. Oh my god, what kind of 8 is that? Sorry. 8, and then we have 4, and then finally, after that, it leads us to 2. So, let's erase this 8 here. That's horrid. Alright, perfect. There we go. Much better. So, now we have to count how many half-lives we have here. So, the first we have 1, 2, 3, 4, and finally 5 half-lives. So, we have a total, let's write this down here, 5 half-lives, right? Right, so now we know how many half-lives there are, and we know that in total, the 5 half-lives happened over a period of 12.5 hours. So then we can calculate how long each half-life is, or what the half-life is. So it's kind of going opposite from the last question. So this is really the only place where this question is different from the previous one. So you got to be careful there. So we use our total time of 12.5, and divide it by our 5 half-lives, and that gives us 2.5 hours. And that is the length of each half-life. So that is the answer. Each half-life is 2.5 hours. Alright guys, hopefully these 3 practice questions helped you guys understand half-life problems a little bit better, and I will see you guys next time. It's Max signing out.